All right, welcome to math today. We are continuing on learning about addition and subtraction of fractions, and today we're focusing on subtraction. All right, my main question, because subtracting fractions is not that hard. Before we even look at the lesson, I'm going to write something right here. 3/4 minus 1/4 equals what? Before we start reviewing, someone tell me, when we add or subtract a fraction, what do we do with our denominator? Because there's a special rule. Cadence?
First, you leave it the same, and then you add it, and then you subtract 30 minus 1.
Okay, so we only subtract or add the top, right? The denominator stays the same. Okay, we all remember that?
Mm-hmm.
Okay, good memories. Yes, Liam?
It's one of these problems where you can, like, change it into, like, big numbers.
We won't even have to do that today. Today is simple, all right? So I need somebody to read this problem, and this guy's name is Alberto. Okay, Hayden, go ahead and read that for us.
Alberto's 1 liter.
1 liter.
1 liter water bottle had 5/6 of a liter of water in it. He drank 4/6 of a liter. Then what fraction of a liter of water is left in the bottle? And I already know.
Okay. Now, we are fraction subtracting experts. I think we do already know. And by the looks of a lot of you, you look bored because this is easy. Okay, but pay attention. All right, we're going to picture this. So look in your book. I need someone else to read underneath the picture it part. The following model, someone different, or I'll call a victim. Quentin, can you read that little bit for me while I scroll down?
The following model shows the water bottle divided into 6 equal parts. 5 shaded parts show how much water is in the bottle.
All right, thank you, Quentin. So each part's 1/6. Alberto drank 4/6 of a liter. So we take away 4, 2, 3, 4, gone. We have 1/6 left. Okay, now do we need to draw a picture every time we do a subtraction problem with fractions? No, thank goodness, right? That would take a lot of time. So there are other ways you can think about it, though, down here at the bottom. Model it, okay? If we do a number line, which you're all very good at now, he has 5/6 of a liter. We went back 4/6. He ends at 1/6. Pretty simple, right? Any questions on this before I move on off the water bottle page? Hayden?
It's also adding 1/6 and 4/6 is 5/6.
That's true. That's kind of a way you can check it right when you're done. See if you got it right. You got it right, please. All right. Number 9. I need a reader. Connect it. We're going to solve our problem. Someone read number 9 for me. Madeline?
Wait, are we connected?
Yep. Well, the number 9, the problem.
And picture it. Why does 1/6 represent one of the equal parts of the bottle?
All right. Now, brain's on. I'm not coming up with this for you. In the picture it, so go back to Alberto's water bottle. Why does 1/6 represent one of the equal parts in the bottle? Noah?
Because there's 6 things in the bottle.
Is it split up into 6 equal parts? That's why. 1/6 is one of 6 equal parts. It's pretty simple.
Why do people
All right, now I am going to write our fractions here since I don't have the picture on my page. Hello. All right, guys on home watching, I'm going to pause you a minute. All right, we are back, friends. Okay, we are ready to answer number 10, and I was just writing down my fractions so I can look at them. I have 5/6 and 4/6. Now all I want you to think about is what this question's asking. What do the numerators, 5 and 4, tell us? Okay, think about Alberto's water bottle. It's not telling us how many total parts there are. What is it telling us? Hayden?
It's telling us that there would only be 1/6 left.
You're thinking too hard. What'd the 5 mean when they said there's 5/6 of the water in the bottle?
Like subtraction?
Well, it is setting us up for our problem to subtract, yes. But what did the 5 actually mean? Noah?
5 liters in the bottle.
That was how many equal parts were in the bottle, right? Okay, so the 5 and the 4 tell us how much water is in the bottle and how much water he drank from the bottle. Does that sound good? Okay, the 5 was how much he started with, right? Look at your picture on the opposite page. And then he drank 4 liters, right? Ended at 1. So you can borrow my words if you would like. The 5 tells us how many equal parts he started with. All right, fast and get out of your way. And then the 4 tells us how much he drank.
How does the 4 show how much he drank?
Well, look at your picture. You see the part in the red where he boxed off 4. So he started with this much, and then he drank that much, right? He must have been thirsty. He only had that much left. So he started with 5 equal spaces. He drank 4 of them. Okay, you can think about that right now. All right, number 11. How many sixths of a liter are left in the bottle after Alberto drank 4/6? This is the answer to the problem. I know you guys know this. I'm going to call a victim. Thank you, Quentin.
2.
Are you sure? Look at the picture. How many sixths are left in the bottle?
1.
1/6. Nice job. Complete the equations to show what fraction of the liter is left in the bottle. Now this is so easy, okay? But sometimes when we write it out like this, it just looks funny. If we're using words, we have 5/6 minus 4/6, and Quentin just said we have how many left? Chloe? So 5 minus 4.
It's kind of in
1.
word
Okay.
form.
All right, now what about using fractions? Pretty easy. I just need you to tell me, William.
1.
1. All right. Let's just chat about 13. Is that okay with you all? Instead of writing it all down? But I need someone to raise their hand that hasn't answered in a while because some of you have not answered your one question of the day yet. How do we subtract fractions if they have the same denominator? This question should not be a tricky one. If we have the same denominator, Liam, how do we subtract the fractions?
You keep the denominator the same and subtract the top.
Excellent, okay? If you can remember what Liam just said, you've got it, okay? Can someone repeat what Liam just said? Cadence?
Keep the bottom the same or out of subtract the top.
Excellent. All right, trick question. What if my denominators aren't the same? And Mrs. Hare says, add these up. What should you say to me? Hayden?
You have to,
You can politely say it to me, but what would you have to say to me? Can you do it?
well, yeah, and you
If your
have to-
denominators aren't the same?
you could change.
Oh, you'd have to change them. Okay, but we haven't even done that, right? All right, I think you guys have got it. We're going to try it down at the very bottom. And that's it for today. Does someone want to read the first one? Noah, go for it. Mr. Kirk.
Mr. Kirk
Or
had
Mrs. Kirk, I'm sorry.
Mrs. Kirk had 3/4 of a carton of eggs. She used 2/4 of the carton to make breakfast. Which fraction of the carton of eggs does Mrs. Kirk have left?
All right, we're going to write a number sentence. What fraction of eggs did she start with? Angie, how many did she start with?
3/4.
3/4. Okay, we'll write that first. All right, now the hardest part of this is deciding are we adding or subtracting, and that's not that hard. Hayden, what do you think?
Subtract.
All right, because she used some of the eggs, right? So we have to take away some. What fraction are we taking away? Madeline?
2/4.
2/4. All right, the last thing I need to make sure that my denominators are the same. They are. So I just copy that over,
This one.
and my numerator will be what? Chloe? 1/4. Nice job. Questions on that one? All right. Number 15. I need a reader. Cadence.
Anna has 8/10 of the lawn left to mow. She mowed 5/10 of the lawn. Now what fraction of the lawn is left to mow?
Okay. So we have to subtract, but how much did she have to mow at the beginning? What did she start with having to mow? Zoe? What did she start with? When she started mowing, how much of the yard did she have to mow? 8/10. So that's what we start with. She had that much to go. And then how much did she get finished? Emma?
5/10.
5/10. So if we subtract that from 8/10. All right, someone tell me my answer, but explain how you know. Angie?
3/10.
Okay, why didn't it become a 20, Angie?
Because you can't add. You said that the denominators even if you add and subtract stay the same.
That like the number one rule? Yes. Okay, who remembers what type of problem we do change our denominators in a fraction? Because this is when sometimes students get confused. When we add and subtract, they stay the same. What two operations do we actually change them? Hayden?
When you want to make them equivalent.
Okay, so that's when we multiply and divide, right? Yeah? You guys with me? I can see that we're very sleepy today. Okay, I'm guessing some of us stayed up a little too late last night.
I didn't stay up too late.
All right, just remember, adding and subtracting, leave your denominators. All right? Friends at home, I know that was a pretty easy, quick lesson today. I hope you have a great day. We'll see you soon.
Bye-bye.